Okay, I thought I would start this off with a little discussion about what integration by parts is. Now, when you were in Calc 1, you did derivative of a product. And you called it first, second, or whatever, FG, or if you want, UV. And you would do first derivative second plus second derivative first. But like I said, all of the calculus 2 techniques are significantly more complicated. It's not as simple as just this times this. In order to reverse the product rule, you actually have to have this. So you have a U and a dV. So it's a lot more complicated because going in the opposite direction is more complicated. So you're going to always pick a U and whatever's left over is a dV. So the formula goes, if you're trying to integrate something that looks like U times dV, it's U times V minus the integral of V du. So that was the formula. Now, again, the hard part was picking what you want for the U. That's why I said, always remember to be late, except not to class. So the L stood for logarithm. So as long as you see something, no matter what it is, it could be anything, but as long as you see ln there, doesn't matter what type of ln, could have anything with it, could be a 2x. As long as you see ln, log, that's what you pick for your U. It won't work otherwise. The problem will never work out for you if you make a wrong choice. That's why this is really critical. Then the second thing you're going to pick, the A stands for algebraic. And that just meant stuff with x's in it. So now you assume that there isn't a log there. So you have something like x third and sine x, or you have something like x squared e to the x. Again, something with x's in it is algebraic, so that's who you're going to choose over anybody else. Now, the third thing, again, this assumes that there's no log and there's no algebraic stuff there. So there's either a trig thing there or an exponential function there. And given that choice, and believe me, this if you're here, this is a very bad choice. You have to pick the trig thing over the e thing. You will never, ever, ever pick the e thing unless there's nothing else there. And if something like that were to happen to you, this integral would be ridiculous. There is a way to put them together using exponent rules, but it's still not going to work out nice. So logarithm, algebraic, trig, exponential. Now, sometimes during these questions, you'll end up with stuff like this. You'll have a chain rule mixed in, right? Like let's say it's sine 4x. There's one like that that'll work in the next set. So this is important because you'll see these all the time. And you have to recognize that, right? It's a reverse chain rule, right? It's a calculus 2 U substitution. So this is not just e to the x. Integrating e to the x is very simple. Integrating e to the 2x or sine 4x is more complicated. So I'm just going to review really quick. When you encounter them, you don't have time in these problems. These problems are really long and complicated. You don't have time to sit there and do a U substitution in the middle of the question when you're trying to do the U dv thing. So, if you're integrating something like this, it's very simple. There's supposed to be a 2 here. Why is there supposed to be a 2 there? Because when you take the derivative of e to the 2x, it's e to the 2x times 2, right? You multiply it by the derivative of the power. So there should be a 2 there. But there's not. There's a 1 there. So when you integrate that, you have to adjust for that. You'll put the e to the 2x, right? The e to the u. But you need a 1/2 here. So basically, whatever this number is, if I want to call it, a, then you would just put 1 over a, whatever it is. And it helps you because no matter what number is here, you can offset it when you do that. Same thing with the trig ones. Let me do the easy one since I know the derivative of sine is cosine. If you had like cosine 3x, I know I'm not writing my dx, and when you integrate that, you're going to get sine 3x. But if you were to check it and just take the derivative of this, the derivative of sine 3x is cosine 3x times 3, right? Chain rule. You need the 3 in the front, and there isn't one. There's no 3 here. If there was a 3 here, this would have been the antiderivative. but there isn't a 3 there. So where did it go? It got eaten up by this 1/3 that I'm supposed to put there. So you have to remember to put these things, because if you don't put them, then the integral is not going to work. It's going to be wrong. So you have to be very careful. So again, whatever's here, you know, let's call it C this time for constant. Although that looks bad. No, let's not. Let's pick D. Little d for dumbass, or whatever, something like that. So if there was a little d there, then you would have to put 1/d to cancel that out. And this is, that's about as complicated as it gets. But you're gonna be doing these little baby u substitutions within the integration by parts. You'll see when I work the examples. But like I said, I wanted to do a little introduction video where this is the key. Because like I said, if you're doing a problem and you don't pick the correct u, right? You're always picking a u and you're picking a dv. You're supposed to pick log over everybody, but if you didn't do that, if you put x to the third as the u in this question, now you gotta find an antiderivative of this. You have to integrate ln x. This is a really complicated integration by parts integral. You can't. It doesn't work. You can't. You have to always pick that. The poor choice of u is going to always run into a dead end. So you have to follow that late thing. And again, you're going to expect those u substitution chain rule antiderivatives to pop up within the problem. All right. So this is a little introduction, and I'm going to work examples from the sheet, and then I'm going to do more complicated examples in another video.